In progress. Good afternoon. So today is the last week for lecture. So we're gonna finish all the lecture this week, and which is Monday and Wednesday, and then we're gonna have 1 week, which is next week. It's just for you to prepare the case project, and the following week you're gonna have a presentation. Okay. So let me share the screen on the our schedule on my course. So this week we're gonna study chapter 13. Okay, week 13. We're gonna study chapter 13. You have assignment. Okay, due this week 13, and in week 14, please work on the case with the members in your group. You need to prepare a PPT, slides for group presentation, and the research paper for the case. In week 15, which is the week after next week, it's time for the groups to present the case in class. Each group has 10 minutes for presentation, no more than 10 minutes, and 5 minutes for questions. For the presentation, please focus on the exhibits, tables, and figures provided in the case, and show us what they are telling and how it related to the topic. Okay, research paper due at the end of the week 15. Okay, please email me the slides which you're gonna present 2 days before your presentation, so that I can give you some suggestion, and your research paper can be sent by email too. Okay, and also I posted the guideline for a report and presentation. That's about the next 2 weeks, okay, for case and the presentation reports. That would be our main work for the next 2 weeks. Any question? Any question?
Yeah. Do we all have to pass in a final report individually, or is it just one per group?
The reports, one for group. Yes, reports, just one for group. So put all the students' name on the cover page. Okay. And for presentation, everybody need to participate. So you need to distribute the each part to each student. Any other question? Final exam would be the week after presentation. So the specific date based on the school policy, school schedule. Our final exam would be May 4th, Tuesday. Okay. Tuesday from 11:30 to 2:30. So we have 3 hours. You have enough time to do the final exam. Final exam similar to the format similar to the first 2 exams. Okay, but the material will cover chapter 10, 11, 12, and 13. So we have 2 chapters, which is we talk about the we also covered in the second exam. Okay, so any question? Any other question? So we're going to talk about exam 3 a little bit more later, next class. Question? Okay, chapter 13. So chapter 12, we basically talk about the binomial tree model, right? We use binomial tree model and the 2 different assumptions. We make we calculate the option price, and we use different approach. We get the same answer, right? So that's about the chapter 12. Chapter 13, we're gonna use different model to calculate option price, which is called the Black-Scholes-Merton model. Okay, BSM model. So first, before we talk about the model, we're going to talk about the volatility of stock price change first, and then value of European call and the put option on a non-dividend paying stock. So we simplify the case, which is the stock not paying dividend. If the stock paying dividend, the calculation would be more complicated. BSM model, we're going to talk about the assumptions, and then we're going to talk about option price. For BSM model, we have assumptions. So first we talk about assumption about how stock price change. A stock option pricing model must make some assumption about how stock price change over time. BSM model basically consider a non-dividend paying stock and assume that return. So what is return? Return basically the price change, percentage price change, right? So the other S, which is the stock price change and over stock price, previous stock price on the stock in a very short period of time. Okay, the return on the stock in a very short period of time. So we use delta T, which is the time period. Okay, could be daily, could be weekly. So which is we call it a very short period. Is normally distributed with mean, we use mu times delta T. And the standard deviation, we use sigma and the square root of delta T. Okay, mu is expected return and the standard deviation is volatility. You don't need to how they're gonna get them, but you need to know how to use it. Okay, use them. So first we talk about volatility. Volatility of assets basically the standard deviation of its continuous compounding rate of return in a year. So volatility is the standard deviation. Okay, volatility. Then if you know volatility per year, will you be able to calculate volatility per very short period, for example, per day or per week? So in this slides, we use this, just means all, which is per day or per week, okay, not divided by. So per day or per week. For volatility per day or per week, we calculate it by volatility per year, per annual, which is a year, times square root of number of trading days. And again, this is all, means all, not divided by, okay? All weeks in a year. So here is the standard deviation per year, volatility per year, standard deviation per year, times square root of delta T, okay? That's delta T is the number of trading days or trading weeks in a year. Okay, that's about the formula. And here is the total number of trading days in a year. That's like a common sense by default. The total number of trading days in a year is usually 252, okay, not 365. 252, okay, for stocks, because stocks not trading like over the weekend, right? So we will not count the weekends. The total number of trading days is 252. So this highlight that could be a multiple choice question, right? Ask you how many trading days in a year? 252. Okay, please highlight that. And let's see example one. A stock price is 50. Okay, stock price is $50. Its volatility is 25% per year. Okay, volatility, which is standard deviation, is 25% per year. Question one, what is the standard deviation of the price change in 1 day? Okay, in 1 day. So first we need to know how to calculate the delta T. Delta T, here is 1 day. So delta T is the number of days is 1 day, and the total number of trading days is 252. So this is kind of like how many days in a year. Okay, so 1 over 252, that's delta T. So we know the volatility the volatility per day, which is the standard deviation per day, right? So standard deviation per day calculated by standard deviation per year times square root of delta t. Volatility per year, or say standard deviation per year, is 25%, so 0.25 times square root of delta t is 1 day, and in a year is 252 days, right? So that's the way to calculate the volatility per day, or say standard deviation of the price change per day. Can you tell me what's the standard deviation of the stock price change per day?
I got 0.0157, so 1.57%.
Yes, that's correct. 1.57%. Okay, so that's standard deviation of the price change in a day. So question 2, what is the one standard deviation move in the stock price in 1 day? So since the question 1, we find the standard deviation, and the question 2 ask you what is the dollar in dollar cents, right? In dollar cents, what does standard deviation mean? Okay, so for that means we're gonna do the stock price and the times volatility, or say standard deviation, volatility of the price change per day. Okay, stock price. So stock price is 50, and the volatility per day, or say standard deviation per day, is 1.57%. So what we find is in dollar. So one standard deviation move in stock price will be how much dollar? One standard deviation move in the stock price in a day would be how much dollar?
Round up, I got 79 cents.
Yes, 79 cents. Okay, that represents 79 cents in a day. Okay, so that's in dollar. How much dollar gonna be changed for one standard deviation move? Right. So that's example 1. We look at the volatility per day, or say standard deviation of the price change per day. So that's the answer. Delta t is, first you need to find the delta t, 1 day per day, and over 252 days. Standard deviation price change would be 0.25 times the square root of 1 over 252. And the question 2 asks you what would be dollar cents. A one standard deviation move in the stock price in 1 day would be $0.79. Okay, so that's example 1. Can you try example 2? Similar, but now it's per week rather than per day. So similar questions, but ask you what would be the volatility, or also standard deviation of the price change in a week. So the difference would be delta t would be different, right? Delta t in this case would calculate by a week. How many weeks in a year? How many weeks in a year? And we talk about 1 week. How many weeks in a year?
52. That's
correct. Okay, 52 in a year, and we talk about 1 week. So delta t equal 1 over 52. So the question 1, what is the standard deviation of the price change in a week? We calculate the standard deviation change, also volatility per year times the square root of delta t, right? So 0.25 and the times 1 over 52, right?
$3.47%.
Got a 3.47%. So the standard deviation larger if it's considering week, right? Considering a week, the standard deviation basically 3.47%. Okay, question 2 asking what's in dollar cents one standard deviation move in stock price. So same thing, we calculate stock price times the volatility per week, right? Or say standard deviation per week. So stock price is 50 and the volatility per week 3.47%. So in dollar cents, how much is for one standard deviation move?
174.
Yes. So $1, 1.73, $1.73. Okay, so that's basically the for one standard deviation move in a week. Okay, so we basically talk about the volatility in very short period, which is per day or per week, based on the volatility we know per year. Okay, we do this because later on we're going to do that in the model, BSM model. Question.
No questions.
Okay. Okay, so assumption. Next, we're going to talk about assumption underlying Black-Scholes-Merton model. So similar to the binomial tree model, we have an assumption for Black-Scholes model. For example, no transaction cost, no tax, all security are perfectly divisible, and the stock price behavior corresponding to log normal model with mu and the standard deviation constant, no dividends, and no riskless arbitrage opportunity. Okay, so that's in theory. We have to have this assumption so that we can use the model to find out the option price. The arguments that can be used to price options are similar to no arbitrage argument used in chapter 12 when we talk about the when stock price change are assumed to be binomial. In this case, a riskless portfolio consists of a position in the option and a position in the underlying stock. It's set up but for a very short period of time. Okay, to remain riskless, it must be frequently adjusted or rebalanced. But we do not consider how to adjust or how to rebalance in our class. In the absence of arbitrage opportunity, the return from the portfolio must be risk-free interest rate. Okay, so all the return in the model we are using is risk-free interest rate. So you probably learned this model from other class. So here is the formula for BSM model. So C means call price, and P means put price. S0 stock price. N is function, is cumulative probability function. We call it NX. It's a cumulative probability function. Talk about the probability, for D1 and the D2. You see the formula for call price. Basically, we have two components. First, we can see the stock price times the function for D1, and the minus K is strike price, and we do continuous discounting. You see negative, okay, make sure here is negative. So negative, which is discount. So we basically consider the time zero, right? So time zero, the stock price, and for option, we have a strike price. The K should be at time T, but we cannot compare K and S0 on different time, right? So we have to discount back K to the time zero, and then we do the difference. That's for call price. And the same thing for puts. For puts, we do strike price, do the continuous compounding, which is the present value of strike price, and the minus stock price. So why they are different? Because the expectation, right? They are different. For call option, the investor expects stock price going up, right? And for put option, investor expects stock price go down. Okay. And the D1, D2, how to calculate D1, D2, that's basically is mathematics, right? As long as you know, you do the calculation carefully, you should be able to get that. Okay, so D1 basically equal log ln, that's the function in the calculator, it's logarithm, natural logarithm. And we do S stock price over K, okay, strike price, stock price over strike price, and minus R is risk-free rate, here the plus the standard deviation, which is volatility square variance over 2 times T and over square root of T. Okay, I think this is all plus. This is all plus. Here the minus. Okay, so you see the difference between D1, D2, right? D1, D2. Here it does square. In the slide, it should be correct. Okay, so double check. For D2, you don't need to go through this calculation for D2. Once you find the D1, you can do D1 minus square root the sigma times delta T. That's easy way, right? For D2, you don't need to go through the basic formula. You just do the D1 minus the square root, the sigma times delta T. Okay, so this is the explanation about the formula. We're gonna have examples to see how we're gonna use them. Okay, you don't need to how to get them. You need to know how to use them. So before we talk about the model to find out the call price or put price, we first talk about M function, cumulative probability function. So what is the M function? Cumulative of probability function. I have a table for nx on my course, so you can go to the slides and you will find the table for nx. Please open that. We're gonna use that in class. Okay, and table. Okay, you need this table. We're gonna use that as example. So first, what is nx? Nx is probability that a normally distributed variable with the mean of 0 and the standard deviation of 1 is less than x. Okay, so you see this graph, the dark part. The dark part basically is the arrow for probability x less than this x. Okay, this could be D1, D2. Okay, could be D1. Let's say D1. If it's D1, so nx less than D1 for probability. If x less than D1, so that's the probability arrow. Okay, the whole arrow under this normal distribution is 1. And if it's just a part of them, so the should be less than 1, right? Probability should be less than 1. Okay, so the table, see the table at the end of the book, which is I just showed you. Here's the table. So how to use it, how to read this. Okay, look at this table. Basically, they have 2 pages. One page is for x greater than 0. Okay, x in this x could be D1, could be D2 in the BSM model. Okay, so when x greater than 1, we're going to use the page 1. If x less than 0, sorry, I said greater than 0 or less than 0, we're going to use the page 2. So let's see page 1. you see the table X. I don't think I can make a note on this file. So you see the first column shows 0 0.0, 0 0.1, 0 0.2. So that's for X, the first decimal, okay, 0 0.3, 0 0.4 until 4.0. Okay, so that's for X, define the first decimal. And if you see the row, the first row shows 0 0.00, 0 0.01, 0 0.02 until 0 0.09. That basically defines the second decimal. For example, if X equals 0 0.85, can you tell me what is NX? What's the probability? 0 0.85, what's the probability? Which is the number give you is the probability for X equals 0 0.85. That's M function. What's the probability? Anybody get that? 0 0.85. I said 0 0.85. Anybody get that?
0.8023.
Yeah, that's correct. You see, 0. I cannot make any mark, but you can see 0 0.8. That's the first column. The first column, find 0 0.8, and then stick to this line to go to the 1, 2, 3, 4, 5, 6. The sixth column, you will get 0.8023. That's for decimal 0.05, right? So 0.85, if X equals 0.85 and X equal 0.8023. So which is the probability? 80%, about 80%, X will less than 0.85. Okay, so that's for how we're gonna use this table. Another example, X less than 0. X less than 0, same thing. The first column basically defines the first decimal. So negative 0.0, negative 0.1 until negative 4.0. And the first row basically defines the second decimal, either second decimal 0, 1, 2, 3, 4, 5, 6 until 9. Okay, so let me try one more example. I'm gonna ask the student. So I'm gonna ask a student to answer my question. I'm gonna pick up randomly. So let me get my roster to answer my question. Everybody, please pay attention to class. If you cannot see clearly on my screen, you can open the table from my class, okay? The table in the slides folder. Okay, so let me ask a student, Brian Hall, what I'm gonna ask the X equal negative 0.33. Negative 0.33, what's the M function? What's the probability? Brian Hall, Mike Harris. Mike Harris.
Yes.
Yeah, could you tell me what is the probability, which is the table give you the number for negative 0.33? What's the probability?
0.3707.
Yeah, good. Yes. Are you Mike?
Yes.
Okay. Kevin, Jubani. My question is X equal negative 0.91. What's the probability? Kevin?
Is
Yeah.
it 0.1814?
1814. Yes, negative 0.91. 0.1814. That's correct. Good. Okay, another one. Hannah Ross, x equal 1.74. What's the probability?
1.74. It should be, is it 0.9591?
That's correct. Good. Good. One more. Let's do one more. Tayaba, are you there? Tayaba, are you there? Destiny Smith, are you there? Destiny? Ken?
Yes.
Okay. My question, x equal 0.68. What is the probability?
Is it 0.7517?
Good. Yes. Good. Very good. Okay. So, you guys know how to get the probability from this table as long as you know what is x, right? You see x in this table, we just keep 2 decimal, right? In the notes, they have like 4 decimal, but we can ignore that. We just keep 2 decimal for D1, D2. We find for the calculation. So let's go back to the slides. So example 3, we're going to calculate D1, D2, negative D1, negative D2, and then we're going to use the table to find the probability, okay? So first step, find the D1. D1, remember the formula. If you do not remember, you can go back to the slides. Natural logarithm stock price S0 over K. So this formula, you don't need to memorize. It's in the formula sheet. So you just make sure you use the right formula and over. Okay, so we are looking all the number, looking for all the number. Stock price 52, right? Stock price 52. This is the stock price, and the strike price 50. Okay. Interest rate 12%. Make sure you use 0.12. Okay. Plus standard deviation. Okay, which is volatility 30%. This is the standard deviation. So in the formula we have a square, right? So we have to do 0.3 square over 2, and then time t. T is what? 3 months. So 3 months. A year, how many months? 12, right? So times 3 over 12. And then over sigma 0.3, and over, and the times square root of t is 3 months over 12 months, a year. So first calculate D1. Can you do? So you just need to keep 2 decimal, right? D1, D2, because we the table we can find the 2 decimal, right, directly.
Is it 0.11?
0.01? No, can you try it again? So this calculation are not easy, but as long as you do step by step, you should be able to get the answer. Okay, so just to take your time.
I got 0.54 or 0.5365.
Keep a 2 decimal. Yes.
Okay.
By 4. That's great. Yes. So if you didn't find this number, please do it after class. Okay. Double check. You can get the number. D2, I said that we're gonna based on D1. That's easy. So for D2, we're gonna do D1 minus square the sigma times square root of t. So 0.54 minus sigma, which is 0.3 times 3 over 12. So what is D2? Again, keep it 2 decimal.
0.39.
Yeah, that's correct. 0.39. Okay, make sure you find this two number. If you didn't get this two number, you may not be able to get the probability, right? So you can use the table to one more time exercise to find the n when D1 equals 0.54. What's the probability? So please check. And the D2 is 0.39. What's the probability? Please check. You can go to the table. That's from the first page, right? And we have a negative D1, negative D2. So negative, which is negative 0.54, negative 0.39. That's from the second page of the NX table. So please get the probability for this function. Just take your time, no rush. And if you didn't get the you do it, and I'm gonna ask the student tell me the probability. Okay, I'm gonna ask the student. We have 4 questions, so 4 students. Michael Canal, can you tell me what's the n function? What's the probability for D1? 0.54. If you are not there, let me change. Sam Logan.
Yes.
Yeah. Can you tell me what's the probability for x equals 0.54? Go to the table. 0.54. 0.54. What's the
That'll be 0.7054.
That's correct. Good. So the first one, 0.7054. Okay, D2, 0.39. So let me see. Amani there. John.
So
Yeah.
it's 0.6517.
That's correct. Good. 0.6517. Good. Negative, so negative D1, which is negative 0.54, you need to go to the page 2, right? Because x less than 0. Let me see who else. Kyle. What's the probability when x equal negative 0.54? No. Kenneth,
Yes.
what's the probability when x equal negative 0.54?
It's 0.2946.
That's correct. Good. 0.2946. Good. And the last one, Dylan. What's the last one? Negative 0.39? No. Alex? Darius? Darius?
Yes.
Yeah. Could you tell me like the probability when when x is negative 0.39?
0.3483.
That's correct. 0.3483. That's correct. Good. So looks very easy, right? To as long as you know x, you can use the table to find the probability. Also, you can see something like you can from this answer you can see n d1 and n negative d1. These two numbers add together equal what? Equal 1, right? So you can do find the n d1 and then you do 1 minus d1, which is the these two add together equal 1 and these two add together equal 1, right? So it's up to you. You can use the table to find each number or just do the calculation based on the relationship. So basically it's n d1 plus n negative d1 equal 1, right? And the same thing for d2. N d2 plus n negative d2 equal 1, right? So it's just save a little bit time, right? But it's up to you. You can use either formula to find the negative d1 or you use the nx table. That's both very easy, okay? So today we, to summarize what we discussed today, we basically talk about the assumption, we talk about the volatility per day, per week, and we talk about the NX function, right? So next class, we're gonna talk about how we're gonna use the BSM model to find out the option price. So in the model, we're gonna need to find NX function, okay? N function. So we today example 3, we just did a part of them. Okay, so next class we're gonna talk about example 4, and we have time. I'm gonna just give you a quick review about the final exam, and we're gonna talk about a little bit about the project if you have a question. So next class, that's our plan. Any question? So next Monday is like holiday, right? So no class, and Wednesday we don't have class because I give you for project, okay, to do the project. Any question?
No questions.
Okay, no question. Okay, so student didn't Okay, that's fine. Amani, that's fine. So next class, we're gonna conclude all the lectures, and also I'm gonna arrange the order for the presentation. So if your group prefer Monday or Wednesday, let me know. Okay, if you didn't email me about the date, so that means you are fine for either day. So that's okay. So I'm gonna do that. And I think we have 7 groups, so probably 3 and 4. Okay, so let's see. That's all for today. Any other question? No. So you're gonna have still have assignment due this week. Okay, you have assignment due the end of this week, and we're gonna finish chapter 13 on Wednesday. That's all for today. Any other question? You can email me. Okay, still you can email me any question if you have. Okay, that's all. Have a good day.
Thank you.
Have a great day, Professor.
Yeah.
Thank you.
Yeah, thank you. Bye.